So, this is the next concept, the last concept of this section. Is called the intermediate value theorem. There will be one of these on the tests. You do need to know how to apply the intermediate value theorem properly. It does have some conditions that you have to meet, and you have to state that you meet them before you can draw the conclusion. So let's see how this goes. It says, if f is continuous on the closed interval a to b, and f of a is not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in the interval a to b such that f of c equals k. So let me just show you what the heck they just said right here. Imagine a function is continuous on the interval a to b. So that means you can draw it without lifting your pencil, right? You can draw it without lifting your pencil. Then it had to state that these two endpoints aren't the same. There has to be some room between them. So that means you have to be able to go from f of a without lifting your pencil to get to f of b, right? From the x equals a value to the x equals b value, you have to be able to get those. So what the intermediate value theorem says is pick a y value in between those two the y values of the endpoints. There has to be at least one point, at least one x value in between a and b, at least one x value in between a and b, where we actually have that function value right there. So where f of, in this case, c2 would equal k. So if you find a y value between the endpoints, between the two y values, there has to be an x, at least one x in that interval that has that y value. There has to be a point that reaches that y value. That's what the intermediate value theorem is. I think of k as the intermediate value between a and b, okay? So the intermediate value theorem does not find the value, it merely states the existence of a point. There has to be a point. That's what the intermediate value theorem says. So let's read this. It says, remark, the intermediate value theorem tells you that at least one number c exists. You have an x value where you have the given y value when you plug it in. But it does not provide a method for finding c. The intermediate value theorem states that for a continuous function f, if x takes on all values between a and b, then f of x must take on all values between f of a and f of b. So if you take on all x values between the 2 points, then you have to take on all y values between the 2 points as well. And that only works if it's continuous, because you're not lifting your pencil, you're not jumping, not skipping, or anything like that. It says, as an example of the application of the intermediate value theorem, consider a person's height. A girl is 5 feet tall on her 13th birthday and 5 feet 2 inches tall on her 14th birthday. Then for any height h between 5 feet and 5 feet 2 inches, there must have been a time t where the height was exactly h. So pick any height between 5 foot and 5 foot 2 inches. For instance, 5 foot and a half of an inch. There's some age, some point in time between her 13th and 14th birthday where she was that exact height, which would be 5 feet and 1/2 inches. Okay? There has to be a point in time when it occurred. It says this seems reasonable because human growth is continuous and a person's height does not abruptly change from one value to another. So the intermediate value theorem guarantees the existence of at least one number c in the closed interval a, b. There may, of course, be more than one number c such that f of c equals k. So there might be more than one x. A function that is not continuous does not necessarily exhibit the immediate value theorem property. So if you have any skips, humps, or jumps, holes, anything like that in your graph, you cannot apply the intermediate value theorem. So it is absolutely vital that you meet the conditions, which is that it has to be continuous and that the endpoints have to be different. So I wrote this up. This wasn't in the textbook, but I wanted you guys to see this. If you want to apply the intermediate value theorem, this is what I'd be putting on my note card because this is what I expect to see in your work. The first thing you need to do is state that the function is continuous on the closed interval. And it's very important that you say the closed interval because we do have to include the endpoints here, okay? So state that the function is continuous on the closed interval. Find the endpoints. Find the y values, right? So it says determine the desired value of k. So let's say you have a y value of 10 and a y value of 5. Determine the desired value k. Well, that's usually what's given to you in the problem. They'll tell you what it is. So if we had a y value of 5 and a y value of 10, they might want a place where the y value is, let's say, 8. And it says if that y value, in this case 8, is between 5 and 10, if that y value is between your two other y values, then the intermediate value theorem states specifically that you must meet that level. You must meet that intermediate value. There has to be a point C where you have that y value. So all you have to do is set the function equal to that y value, solve, and you can solve for x. And that's how you would actually find it. So let's look on the next page to see some applications.